All right, so I think I have this one actually written correctly with all the proper numbers here. It says a random sample of 50 homes had X bar equal to 396.3. I think this, I kind of abbreviated this. I think this problem is sale prices in thousands of dollars or something like that. But anyway, a random sample of 50 homes had X bar equals 396.3 and S equals 150. Using alpha equal 0.05, do these data support the hypothesis that the mean is more than 366.5? A random sample of 50 homes had X bar equals 396.3 and S equals 150. Using alpha equal 0.05, do these data support the hypothesis that the mean is more than 366.5? So now, see if you can work this out, and I'll work mine out and see if I can match your work. So go ahead and pause the video now. All right, so now let's see if I can catch up to you guys. First, I'm going to state the hypotheses. Let's see, hypothesis mean is more than, so I'm going to say mu more than 366.5, and if I have that, that means this has to be less than or equal to 366.5. Number two, I believe there is an alpha given this time. It's explicitly given to be 0.05, so we're good to go there. Number three, there's the data. And the data, we have n equals nice and neat 50. We have X bar 396.3 and S is 150. The test statistic is T is equal to X bar minus mu sub 0 over S over the square root of n, and degrees of freedom are n minus 1. So let's see, X bar is 396.3 minus mu sub 0 is right there in front of me. Here we go, 366.5 from the null hypothesis. 366.5 all over S was, where's my number, 150 over the square root of 50, and degrees of freedom are 50 minus 1. We have 49 degrees of freedom. And so let me see if I can do my computation this time. I have, here we go, open parenthesis, 396.3 minus 366.5, close parenthesis, divide by, open, 150 divided by the square root of 50, close parenthesis twice, and I have 1.405 I'm going to use. I actually have 1.4047. I'm going to round that to third decimal place, 1.405, and degrees of freedom are equal to 49. So that's my step 3. That's my test statistic. Let's see, where do I go now? Well, that's why you number them. After step 3, that's why we have step 4. And step 4 says I need to find the p-value. And the p-value is, oh goodness, the p-value is in 49 degrees of freedom. 49 degrees of freedom. I need to find the two numbers between which 1.405. 1.405 in the 59 degrees of freedom row. 1.405 in the in the 49 degrees of freedom row. I have 1.299, which is less than 1.405, which is less than 1.67, I'm sorry, 1.299, 1.677. All right, we'll double check that. I'm in the 49 degrees of freedom row, 1.299, 1.405, 1.677. Yes, I have found the two numbers between which that falls. This number gives rise to the p-value. All right? Reverse the direction of the inequalities. Go ahead and reverse them. You know that has to happen. And then we need to find the numbers at the tops of those columns. 1.299 in the 49 degrees of freedom row, top or bottom, because this table is so well described. This is 0.10 and 0.05. So I think this has not yet happened in any of our work. I'm not sure. But so that's my values here. Into this inequality string, we need to insert the value of alpha. And what happens here is, well, that's fine. Alpha is already in the inequality string. That's alpha. Alpha is baby bear. That's all we need to know is where does it fall in this inequality string. Step 5, decision. We have p-value, always write p-value first, always write alpha second. And so, in our case, p-value, here it is, it's smacking you right in the face. P-value is bigger than alpha. Mama bear is bigger than baby bear. P-value is greater than alpha. Our decision rule is reject the null hypothesis if the p-value is less than alpha. Reject the null hypothesis if the p-value is less than alpha. So our p-value is not less than alpha, so we do not reject. If you write this, that is not correct. That is not correct. You need to state which hypothesis you're not rejecting. If you say do not reject, then we don't know for sure which one of these you're not rejecting. And so do not reject. You should always write the null hypothesis. Either reject H sub O or do not reject H sub O are the only two, for our purposes this semester, those are the only two legitimate conclusions from any hypothesis test. So there we go. That's an example all worked out.